Welcome to our evening on amphibians and wetlands with Elke Wind. I'm going to repeat myself here. Elke spent more than 20 years studying amphibian populations, specializing in their habitat needs in relation to timber harvesting, rural and urban development, and non-native species. She's built or restored more than 20 wetlands and written numerous reports for governments, species recovery teams, and non-profit organizations. She volunteers with BC Nature Kids, the Society for Northwest Vertebrate Biology, and partners in amphibian and reptile conservation. Welcome, Elke. It's a privilege for us to have you. The digital floor is yours.
Great. Thanks very much, Guy. And I really appreciate the Yellow Point Ecological Society for having me this evening. Let me just share my screen here. Bear with me.
It says frog park.
There we go.
One more. There you go. You're on. Yeah.
Okay. If you decide that you want to be watching me throughout the talk, if you haven't done this before, if you move me up to the right-hand corner of your screen, it shouldn't block any of the text that's going to be on the screen or the images. So what I'm going to be talking about tonight is called Why Landscape Context Matters in Wetland Conservation. And I'm going to have three main parts to the talk. The first one is a basic introduction about what landscape is for an amphibian. And then I'm going to go through two case studies that highlight sort of the thesis of the talk. The first one I'm calling Forestry and Frogs, and the second one is Roads and Toads. And I would prefer if you have any questions, if you just type them into the chat box and we can look at them later, just so that there isn't too much sort of disruption throughout the talk. That would be great. So what is landscape for an amphibian and why does it matter? So we have 20 native amphibian species in British Columbia. Only 13, or I should say 13 of them, which is 65%, breed in lentic habitats. So that's standing water such as ponds, wetlands, and lakes. As you may know from the media, over the last 15, 20 years or so, there's been fairly significant population declines for amphibians around the world, and about 32% of amphibian species are threatened with extinction. Habitat loss and degradation, like with most wildlife, are considered to be the major threat, but amphibians are also facing other stressors such as pollution, invasive species, and disease. And so in terms of habitat loss and degradation, that would be things like wetland drainage and landscape fragmentation. Amphibians are unique invertebrates in that they require moderate, moist climatic conditions. And that really affects sort of where they are and the way that they're behaving. They require these conditions for two main reasons, or for one significant reason, and that is that they have semi-permeable skin, meaning that moisture, oxygen is moving sort of in two directions through their skin. So they're susceptible to drying out. They're also susceptible to pollutants and chemicals. And because of this sort of unique skin, they're tied to moist microcytes. So some amphibians are breathing 100% through their skin. We have what are called lungless salamanders, but all amphibians are breathing to some extent through their skin. But in order to have that work on a physiological basis, their skin needs to stay moist. So they're usually seeking some sort of vegetative cover, or they're in or under downed wood or underground in order to stay within a moderate thermal condition and to keep that moist skin. So what is landscape for an amphibian? Let's look at what they're doing throughout the year to understand what this is. If we look at the left-hand side here, I'll see if my mouse is going to work here. Throughout the winter, they're in what we call a winter dormancy. It's not an actual hibernation, but they're in a state of torpor, and that's generally it could be anywhere as early as November, December into March or so, depends on the year. And then these adults are waking from this hibernation and they're migrating towards the breeding site. In this area, it's around April or earlier. And then the eggs and the tadpoles are in the wetland throughout the spring and summer. And the adults are moving away from the wetland up into this spring or summer feeding ground. As we go farther into the summer, the metamorphs, so the tadpoles and the salamander larvae are metamorphosing, and they're coming up onto land and dispersing into terrestrial environments. And that can be anywhere from June into September. And then starting in the fall, as early as September, when the first rains start to hit, we see a migration of amphibians towards those winter hibernation sites again. And that's for the juveniles that have just come out of the wetlands and for the adults on land. So the exact timing of these different scenarios varies by species and by geographic location. And then of course the year, the climatic conditions. But what I want to emphasize here is that some species are spending up to 10 to 11 months on land. So they're very terrestrial, a lot more terrestrial than people tend to be aware of. The majority, as I've just said, of our native amphibians actually breed in water, but then spend most of the year in terrestrial environments. When amphibians reach sexual maturity, and that can vary from about 1 to 5 years before they reach this, most individuals return to their home water body. So the water body that they came from is where they will, most of those will actually go back to breed. So they're like salmon in that way. They can actually find their way all the way back to the pond that they came from. So amphibians are very faithful, or what we call philopatric, to these breeding sites. But telemetry work is showing that they also can be quite faithful to their summer home ranges, and our research that I'm going to be talking about later, potentially also to their overwintering sites. So most species are very dependent on both aquatic and terrestrial habitats, and they need to move freely between them on a seasonal basis. Amphibians live in what are called metapopulations. So if we think of a landscape where we have a number of different sized water bodies, that's these little circles on the bottom of the screen, we have a few larger, more persistent water bodies where we will have low but predictable reproductive output. But then we have a lot of very small water bodies that we consider more opportunistic sites. So when the weather conditions are good, the amphibians will be utilizing these small water bodies, and when we have a great wet spring and summer, they can be very, very successful. So in a dry year, we might have a lot of loss in those smaller ponds, a lot of mortality of larvae, and then in a good year, we have a lot of reproductive output. So all of these water bodies within the landscape, all of the populations that are associated are all interconnected. And these smaller water bodies, they may not always be used for breeding, but they're generally used for foraging, for cover, and for hydration. And they may serve as stepping stones for amphibians throughout the landscape. So they're very important. So the overall success of a species is dependent on all of this annual interconnected population fluctuation across all of these different types of wetlands. Unfortunately, our protection of water bodies is very selective. So where we choose to put riparian buffers or to protect wetlands, it's based generally on wetland size or where we're trying to meet fish management objectives. As well, we tend to isolate wetland populations through the permanent loss of forest cover, building roads, and draining and filling small wetlands. So they end up being completely isolated, as you see in the lower ortho image, with urban development in urban areas. So the first study I'm going to talk about is my forestry and frogs research study. And this is a collaborative project that's actually been going on for many, many years. In terms of the 2020 field season that I just completed, it was a partnership with Mosaic Forest Industries with funding from the Habitat Conservation Trust Foundation and some support from the provincial government. But the study's been going on much longer and has had a number of different forestry companies involved. In terms of a study background and how it all sort of came about, timber harvesting has often been cited as having a negative effect on amphibian populations, but there is some variability in the results that seems to be associated with different species and geographically as well. A lot of the research has taken place on populations within terrestrial environments or on stream breeding species. So we hadn't seen any work specifically on wetlands before this work that I conducted. In British Columbia, I want to highlight that small isolated wetlands are not afforded riparian protection with forest practices. So if you're here on the coast, anything less than half a hectare doesn't require any sort of riparian buffer. But from an amphibian perspective, half a hectare wetland is very, very large. They're using really small ponds for breeding. Research has shown that frogs and toads are attracted to low canopy cover wetland conditions. So when it comes to forest harvesting, there are a few things that we might be concerned about in terms of these small wetlands and amphibians. There could be direct mortality during the forest harvesting. There's the loss of the actual forest cover. There's the barrier, a potential barrier to movement because of the clear cuts that are created and the change in the thermal conditions there. And then what I was more focused on with my work is the potential that wetlands could become unsuitable for amphibians once they were in a clear-cut environment. They could potentially, for example, dry out too quickly. We might have increased mortality. So back in 2000, I was involved in a larger study that was investigating the effects of variable retention, or VR, harvesting on biodiversity on Vancouver Island. So this was initiated back in the days of McMillan Bloedel here in Nanaimo. And amphibians were one of the indicator groups that they were looking at. So at the time, McMillan Bloedel was interested in potentially not having any more clear cutting. And so they were looking at different types of harvesting models. And amphibian breeding was something that we were commonly seeing in ponds, in cut blocks, while we were sort of setting up this project. What I also noticed was that small wetlands were often used as the anchor points for where they were leaving these small tree patches in this VR harvesting model. But they didn't have any sort of biological basis for why they were selecting one small wetland over another in terms of where they were leaving these trees. And there was a potential that these little tree patches were potentially acting as buffers for these small ponds, riparian buffers. So I had two sort of primary objectives with this project. The first was to experimentally determine the effects of forest harvesting on the duration of the hydroperiod. So how long were these wetlands, how long were they staying wet within the year? So what was the suitable hydrological period for amphibians within the year and then across years? And then I was looking at breeding. Were they using the wetlands before harvesting, and would they continue to use them after harvesting, or would they potentially use new ponds for breeding? So that was those were sort of the primary questions. Secondary, I'm interested in looking at whether there are some potential indicator variables that may reflect suitable breeding habitat conditions of small ponds. So there's 3 study sites. I'm just going to sort of walk you through this, and hopefully it doesn't get too confusing, but they're sort of in the heading towards the Nanaimo watershed, just southwest of Nanaimo. And the names of the 3 sites are Bear Creek, Dunsmuir, and Reinhardt, which is just related to the logging roads that they're on. So the 3 sites are, for those who know the Beck categorization, they're all within the XM Beck variant. The size of the cut blocks, or the patches, varied from 8.5 hectares up to almost 22 hectares. 2 of the sites were over 300 years old before harvesting. The 3rd site was only 85 to 88, but it had some fire history. So none of them had actually been harvested before. They're all within just over 300 to 400 meter elevation, and they all had over 20 small wetlands within the block. So I went in the first year in 2004, and green indicates that the site was in the pre-harvest condition, so it was all forested. So at all 3 sites, I was able to collect pre-harvest data in 2004. And then there was a bit of a miscommunication, and unfortunately the Dunsmuir site was harvested early. So I was able to get a 2nd year of pre-harvest survey data in 2005 at 2 of the sites. And then by 2006, all 3 of the sites had been harvested. And I collected data in 2006, 2007, so the 1st and 2nd or 3rd year after harvesting. And then I was lucky enough to go back this year. I got some funding to go back in and look at the post-harvest condition 15 and 16 years after harvesting. For the amphibian data, I was conducting 2 different types of survey techniques. I was using 2 different techniques, and then I was also measuring a number of habitat variables, which I'll go through. For the amphibians, I was conducting a visual survey. So I would visit each pond every 2 weeks from April to September, and we would walk through and conduct a visual survey. Some of the species or life stages can be quite cryptic and difficult to detect. So in order to increase my detectability, I did 2 nights of funnel trapping at the end of May or early June at each of the ponds as well. And that's an example of a funnel trap here on the right on the bottom. In terms of habitat, every 2 weeks when I was there, I would measure the water depth at a predetermined maximum water depth location. And then I would measure the water temperature at that site as well. In 2020, I also had some data loggers that I was able to put in that would record the temperature every hour. And part of the reason why we did that was because I'm only going in every 2 weeks, at some point when the pond dries, I don't necessarily know exactly what day it dries. And so we were wondering if the data logger would be able to show some sort of indication of when it might have dried by having a sort of a spike in the temperature. And then at some point in early June, I went in and also did just a general wetland description. Generally, it was sort of visual estimates of canopy cover and the amount of vegetation within the pond, a little bit of information around the amount of open water, bare ground, and the downed wood. One thing I want to emphasize is with these data loggers, what I did is I came up with a clever way of cutting a pool noodle that had a hole in the middle into little 1-inch slabs. And then I tied the data logger to the pool noodle, and it was put on a bamboo stake. So as the water level dropped, the data logger would stay at a consistent depth. What I didn't realize was that the pool noodle seemed to be particularly interesting to some sort of wildlife, because often we would come to the pond and the thing would be ripped off the stake and chewed up, and the data logger luckily was always found on the bottom of the pond, but we didn't understand what was so interested in these sponges. So we put out some wildlife cameras to see if we could find out what it was. And we did find that we were having visits by raccoons at the wetlands. We had mink come at the wetland. But finally, during one of the shots, we managed to get the culprit. We had a black bear come in across one of our sites. Then he proceeded to walk straight towards the stake, which is right here. And then you can see him up close there. He's got the sponge and the hanging data logger right in his mouth. So I think they think of it as chewing gum or something, and bears just love to chew on things. So I think we figured out what it was. So I'm going to go into some of my results, and hopefully it's fairly clear to you. So at 2 of the 3 sites, again, this is something I need to actually do some analysis on in relation to the actual amount of precipitation. So at this point, I'm just looking at it graphically. And the pattern is suggesting that 2 of the 3 sites, the wetlands were deeper after harvesting. So what you have on the bottom are all the different years that we were in surveying, and then the 3 different bars represent the 3 different sites. So the purple bars are the Bear Creek site, and when it has black around the bar, that indicates the first year that we're in the post-harvest conditions. So these are the 2 years, 2004, 2005 is when it's forested. 2006, 2007, and 2020 are after it's been harvested. So it looks like the site is generally wetter after harvesting. With the Dunsmuir site, we had quite a difference. This was actually the first year that it was harvested, and a really big increase in the depth of the water. This is averaged maximum from June to September. But then when we look afterwards, again, a little bit higher than the pre-harvest condition, which is unfortunately only the 1 year, which was a very dry year. When we look at Reinhardt, it's not as consistent. We've got our 2 pre-harvest years here. This is the first year post-harvest, and we have a bit of fluctuation around that mean between those 2 years there. So it looks like potentially we're having deeper ponds after harvesting. And they're not following the pattern for the total precipitation that we had, or the precipitation which was just during the field season. Besides staying wet, that they were potentially deeper, the wetlands also appeared to stay wet longer after harvesting. but we may be starting to see a shift back towards the pre-harvest conditions. So I'm just going to walk you through this here. It's consistent across the next 3 graphs. So these different colored bars moving from the colder blue colors into the warmer colors represents a 2-week period that we went in and looked at the wetland and measured the water depth. And so what we're seeing in general is that we're shifting farther to the right in terms of when the wetland dried. So this is the percent of wetlands within Bear Creek that dried within a given period. So as we see in 2006, 2007, and 2020, they stayed wet right up until the very last survey period, which was the first couple of weeks of September. Whereas in the pre-harvest years, it's shifted more towards midsummer compared to September. So it's very clear at that site. It's not as clear at some of the other sites. Again, it was a very dry year in 2004, so most of the ponds were drying in July, and by the time we get to post-harvest conditions, we're drying in September, except now in 2020, we've had quite a few ponds that dried by the beginning of August. And then with Dunsmuir, again, this was the only pre-harvest year, so the wetlands stayed wet into August in their first year after harvesting. And then we have quite a spread in terms of where they were, when they were drying after harvesting. But again, it looks like there's more of a shift towards some of these later dates that we didn't see in the pre-harvest years. So let's look at some of the characters that are involved here. So these are the amphibian species that we see at these small ponds. This is the Pacific tree frog, the different life stages. We also have long-toed salamanders and red-legged frogs. And lastly, we have some rough-skinned newts, but I'm not going to be presenting data on rough-skinned newts. The eggs are almost impossible to find, and the larvae are also difficult to detect, but they also have just a bit of an odd breeding season in that it's a little more spread out. It's not quite as succinct or obvious as the other species. So I'm just going to be presenting from the other 3 species. So only 2 or 3% of the 68 wetlands that we surveyed had fewer species breeding in the pond after harvest compared to pre-harvest. So the occupancy for breeding before the sites were harvested was about 60%, and then post-harvest it was closer to 80% of the wetlands were used for breeding. The 2 sites where we saw a decrease in species occupancy, they were both at the Dunsmuir site. So one was red-legged frogs weren't breeding at one of the ponds 2 years after harvesting in 2006. And then tree frogs were no longer at one of the ponds at Dunsmuir in 2020. The 2021 is not too surprising. I would expect that as the canopy starts to develop over some of these smaller ponds, we're just going to naturally see fewer frogs breeding in them because of this propensity that they seem to have for low canopy cover conditions. So here you can see it graphically for each individual site, the percentage of wetlands before harvesting and after harvesting that were used for breeding, and for all the sites combined. And this is broken down by species. So each color pair is for one particular species. So long-toed salamander, Pacific tree frog, and red-legged frog. So the darker bars are for pre-harvest conditions, the lighter bars are post-harvest. And again, it's for each site individually and then for all the sites. So what we see is an increase post-harvest for all 3 species in terms of the number of wetlands that they were using for breeding. So this is what we think we know from the data, that the wetlands did not dry faster after harvesting. They looked like they were basically deeper, and that they stayed wetter after the site was harvested. And this is not too surprising for people who understand sort of what's going on within a forested landscape. As soon as you cut all those trees down, you don't have that huge amount of transpiration that's happening, all the water being sucked out of the ground. So it's not too surprising that the wetlands would actually stay wetter and be deeper. What we were interested in seeing was that we did not see any loss of breeding use, or very little of breeding at the wetlands after harvesting. So the harvesting itself was not a barrier to movement, so the amphibians are still able to get to these breeding sites, and wetland use for breeding actually increased after harvesting. And it's most likely that they're attracted to these reduced canopy cover conditions because of the thermal conditions. So these amphibians are trying to have their young develop within one summer. And so the temperature of the pond is critically important to the speed of that development rate. And so they want to be in the warmest pond that they can be in order to speed up that development and make sure that their young get out successfully. In terms of what we don't know is what this actually means outside of the pond itself. What is the actual reproductive success? So we have wetlands in cut blocks, but are they potentially reproductive sinks? My biggest concern is that when these metamorphs are coming out of the pond, they emerge in midsummer, in the driest, hottest time of the year, is what their survival is. So if there's a small amount of vegetative cover and you're a very, very small amphibian very close to the ground, it probably doesn't take much cover to create thermal conditions that are okay. So that's one missing link in this project. We also don't know what the long-term impacts of harvesting are in the face of climate change. And that's where this hopefully continued monitoring of these sites will provide some information on that. And as I said, my analyses are incomplete. So we hopefully everything, the analyses will tie with what I suspect is going on. So I'm just going to move on to the second one, which I'm calling Roads and Toads. And this again was a large collaborative project that took place we started a pilot study in 2014 and it went through to 2017. There were a lot of people involved, and I just want to make sure that I acknowledge the fellow research biologists that are involved, the large number of project supporters and the volunteers, and especially the landowners that gave us access to their land in order to track our toads, and the volunteers that caught our toads. That was very important as well. So how do roads affect amphibians like western toads? Aquatic breeding amphibians, as I've highlighted in the last case study, move between aquatic breeding sites and upland terrestrial habitats annually, and they actually move, there's multiple migrations per year that they're making. We know that amphibians will and do cross roads. They are not a barrier to movement. And in fact, some amphibians like toads may actually be attracted to roads. They have a fairly warm surface. So these guys are coming out in the evening to forage, and they'll go out onto the road and flatten their belly onto the road, and they'll warm themselves because they're cold-blooded animals. So they need to use external factors to warm up their bodies and help with digestion. So they often will go onto the road, flatten their bellies, and try to warm up. Roads are also just much easier to move on. If you've ever been trekking through the woods and then you come across a game trail or anything, you're likely to jump onto that as well. It's just a lot easier to move. And we see that with the amphibians as well. And roads are a unique habitat compared to other habitats. They have different types of vegetation along the roadside. They have road banks, which are fairly loose soil, and they can be south-facing in some instances, which are nice and warm. And then you have the ditch environment where you may get pooled water that they could use for breeding or for hydration or for foraging. And then it could also use that moist environment as a travel corridor when it's dry or hot. We focused on western toads for our research because it's a species of special concern. We've seen some population declines in the United States in the Southern Rockies, and we suspect along the south coast of British Columbia as well. It's an example of a Pacific Northwest species that can be very common, but is vulnerable to decline, and they can decline quite rapidly. Research is suggesting that these declines may have been linked to a fungal disease. Western toads are also vulnerable to roads and urban development. They travel quite far and wide compared to other amphibians. They can move kilometers on an annual basis. And as I mentioned, toads are attracted to roads. Luckily, amphibians the adults tend to move at night. So hopefully that's during the conditions when there are reduced traffic conditions, but unfortunately some still do get hit. The toadlets of toads all move en masse, and they're very directional in the movements, and they're all following each other by the thousands. So if there's a trail or road that is that bisects that movement corridor, then you're going to have a lot of mortality of toadlets. Just to go through a little bit of the history of how we got to our hibernation study, we initially started doing work in the area in Duncan around the Wake Lake site in 2011 and 2012 because we had a concern over toads being killed on roads around this breeding site. So I teamed up with the Ministry of Transportation and Infrastructure to do a road study at that site. So we surveyed roads in spring and summer in 2011 and 2012, and we were trying to locate or identify any potential crossing hotspots so that we might be able to put in an underpass. But what we found was that any potential hotspots varied by species, by amphibian species, and by season. So these are the same images on the top left and the bottom right, but what we have on the top left are the results from the fall surveys, and then on the bottom right, we've got the spring surveys. And so we did our surveys on 3 different roads all the way around the breeding site. And the bar that you see that's green, that's where you have sort of the lowest crossing by amphibians. And as the colors get warmer into yellow and red, that's where you're getting the highest concentration of amphibians found on the roads. So what you can see between fall and spring is that you get a shift. In the fall, you're seeing it more towards the center and north of that river bottom road. And then if we're looking at spring results, it's a little bit farther down and moving actually onto the Barnjum Road as well. So it makes it challenging to try to figure out where you want to put an underpass. If we look at the 2 species at risk that are in the area, the blue dots are the red-legged frogs and the red dots are the western toads. Again, you see differences in terms of where you have potential hotspots. So with the western toads, tends to be sort of in this area of the river bottom road, whereas with the red-legged frogs, we're seeing it more down on Barnjum. So that makes it's a difficult thing to try to figure out where to put underpasses when we have road mortality issues. You have to figure out what your priorities are. So MOT was willing and ready in 2013 to put in an underpass. We recognized, unfortunately, that there are some engineering constraints around that road there in terms of where that underpass could be installed. It had to go a little bit further south than we wanted it to go on that river bottom road. We decided at that time that we were actually going to delay the installation for 2 main reasons. One was that in order to get amphibians to go through underpasses, like what we've got on the bottom here, which is a concrete box culvert, the location of the directive fencing has to go in sort of like a V away from that underpass. Amphibians don't want to go through underpasses. They're dark and cold. It potentially messes with their orientation in terms of how they're orienting on the landscape, what they're using for that. So they don't really want to go in there. So we have to install directive fencing. And that means that you're going out of the roadside environment and now you're moving on to often private land. And so you have to figure out whether you can access that land, who's going to take care of the fencing, it needs maintenance. And we weren't ready to figure out exactly how we were going to do that at that time. So we were holding off. Plus the other major reason was that where we wanted to direct these amphibians into from the lake side out into the west was a proposed housing development. And we didn't want to be sending a whole bunch of little toadlets into a housing development. So we wanted to wait and see what was going on with that land. From that work and other things that were going on, we decided, I was communicating with biologists at the Ministry of Forest, Lands and Natural Resource Operations in Nanaimo, and we decided to look at a study into the terrestrial habitat use and specifically toad hibernation. So why did we study hibernation? There's a number of reasons. One is that toads live on land most of the year. So that graph that I showed you of where they are at different times of the year, they're only really at the wetland for maybe about a month or so during the breeding season, and then they're on land for all the rest of the time of the year. So the terrestrial environment is very important. We know almost nothing about what habitats they use or require when they're on land or to survive the winter. And there's the possibility that the hibernation sites could be as important or more so than the aquatic breeding sites. So there was a toad hibernation study conducted in Alberta, and they found that the majority of their hibernation sites were more than 1 kilometer away from the breeding sites, and that they were communal. So there were multiple toads in each hibernation site. toads don't hang out together. So those two factors suggested that perhaps in that environment, hibernation sites might be limited. So we were curious to see whether this might be the case around this Wake Lake site as well. So how do you study toad hibernation? Well, you have to find the toads, and then you have to fit them with a belt that has a transmitter on it. So there were two main methods that we used to catch them. We had volunteers. We had a big volunteer network in the Duncan area, and we gave a presentation and we told people what to look for and how to hold onto them and put them in a bucket and let us know. And then we were also conducting road surveys starting in the fall at night, especially on rainy nights, and just looking for toads as they're moving through the landscape. When we caught a toad, we had to record the weight and length of the toad and then design a special belt that would hold the transmitter. This belt has to fit on what I'll call the waist of the toad, just above its hind limbs. And it was a neonatal feeding tube because it's nice and flexible and it's not sticky. And then we would insert some flexible jewelry making cord. And then the transmitter at that end had been constructed in such a way that there's a little bit of a tube through here. And so we would thread that stretchy cord through the tube and then fit that onto the waist of the toad. And what would happen is if the toad was moving through the landscape and then the belt got caught on a branch or twig, what would happen was because of that stretchy cord, it would expand and the toad's leg would be able to fit through that gap and then they wouldn't get hung up. So it's very important when you're doing any type of work like this that you're not stressing the animal in any way and then you're not altering their behavior. That's incredibly important because you want to figure out what's going on in their natural behavior. So as well as having that stretchy cord, making sure that they wouldn't get hung up, we made sure that the weight combination of that belt and the transmitter was less than 5% of the body weight of the toad. And what's happening is this transmitter is sending out a pulse that's being picked up by a receiver that we're hanging onto. We're using an antenna, we're figuring out where this pulse is. And what we need to do is relocate the toad every 3 or 4 days in the fall because the pulse has a limited range. And so you don't want the toad to move too far away so that you don't know where they are. So we would always mark the location where we last saw the toad, and then we'd come back in 3 or 4 days, go back to that same location, use the antenna and the transmitter and see if we could hear the pulse that was being sent out. And then you just follow the direction of the strongest pulse. We are working in a rural sort of / urban landscape to the west of Duncan. And that was quite challenging. This is also unique to this study. A lot of research has taken place in fairly pristine environments such as parks and things. So we were working on private land and it was very challenging because they're constantly going onto different properties every few days. So it was a lot of landowner contact and it was incredible how generous landowners were to let us onto their properties. And then also when you're in that sort of a landscape where you've got lots of buildings and trees, you get a lot of signal bounce. So it could be quite challenging at times to figure out where our toads were. Once we moved into the winter and they were settled down underground, we didn't have to locate them as often. Then we just went in once a week. In terms of our results, we captured 61 toads over the 3-year period of our research, and we confirmed 28 hibernation sites. And there were 4 main things we were interested in. We wanted to know when they hibernated, where they were hibernating, whether or not these hibernacula were communal, and how far they were moving between hibernation and breeding sites. What we found was that on average, the toads hibernated for 81 days or about 2 3/4 months, but that ranged quite a bit across years and across toads. So it was anywhere from 1.3 to 4 months. So most of them went into hibernation in November. So these are the orange bars in the graph, and it shows you the number of toads. So you can see it's quite significant for November. And then the emergence varied from June, February, and March. The majority were in January, but this was quite variable across years. So this is emergence in the first year of our study in the blue, the second year of our study, sorry, the numbers are confusing there, but we had 0, 1, and 2. The second year of our study is in red and the third year is in green. So what you see is in the second year, or the first year of our study, the majority came out in February. In the second year of our study, the majority came out in January, and then the last year they came out all the way in March. So that is tied really closely to the weather. So it was a colder year in that third year, and they hunkered down longer and stayed in hibernation longer. In terms of where the toads are hibernating, what was quite interesting to me was that despite the fact that these toads were traveling through and often lingering within what I'll call a built environment, none of our toads chose to actually hibernate under or near any buildings or structures. The exception being that some went into road edges or road banks. There's actually very few of them, but there were some. So 70% of the toads hibernated in or close to areas with relatively open habitat. So they seem to be attracted to likely the thermal conditions. They're probably seeking at least some sun exposure. So 30% of our toads were in forest, but all the rest were either in some sort of edge habitat that had forest on one side and some sort of open habitat on the other, or in a maturing clear cut. So almost a third were in a maturing clear cut to the west of the breeding site. All of our toads were hibernating underground. That's really important for them. They need to get away from freezing conditions. They can't handle being exposed to sub-zero temperatures for too long. So a lot of them were associated with some sort of woody structure, such as large logs or down the root channels of old hollowed out stumps. There were a few that associated with, they hibernated in some sort of mineral bank or like a hill or a mound, but what it looked like when we looked closer at it was that there actually was some sort of wood buried within that structure that created a cavity that they were associating with. I'm going to emphasize here that the hibernation sites or structures were actually not very obvious, and they were very difficult in some cases to find. There were situations where we would hear some sort of a pulse, and we knew that the toad was underground under some sort of, for example, a salal bush. Didn't seem to be any sort of a structure there, and then we had to dig around inside the salal bush before we found that there was actually a big hollow old stump down there. It's just a big hole leading down underground. So that makes it difficult to protect them when you're not even really sure where they are. So we asked whether hibernacula were communal, and we put wildlife cameras at the hibernacula, and that was to meet a number of objectives. One was to confirm that for sure it was a hibernacula, so we wanted to know whether if we could see the toads emerging at the end of the hibernation season. And what we found was that multiple toads were observed at a few of our hibernacula. So we would go through the images and we could see our toad because it would have its little transmitter and belt on it still. But then we would see other toads come out that didn't have belts on. So we knew we had more than one toad. And we did have one hibernacula that was used by toads across study years. We couldn't know for sure whether they were the same toad across years, but we know it was used across study years. So lastly, our big question was how far were they hibernating, or were they traveling in general between hibernation and breeding sites? So on average, it was about 474 meters between hibernacula and breeding sites. Females was quite a bit farther, it was 738, and males was about 342. This makes sense from a behavioral perspective. So you have these amphibians that are hibernating. As soon as they wake from hibernation, they're heading straight to the breeding site. There's no time for foraging or dilly-dallying. They're straight to the breeding site. And the males want to get there first. They are outnumbering the females by about 6 to 1. So there's pretty high competition for those females. So the males arrive early. They want to be probably as close as they can for that reason. The females are actually purposely probably trying to stay back because they're just going to get a lot of attention by the males when they arrive at the breeding site, to the point where some actually end up getting drowned. And so they basically want to move in, breed as quickly as they can, and get away from the males. I want to emphasize here, these 4 individuals are what I'm going to at this point call non-breeders, and we'll talk about them later on. But what we have with toads, we followed them from hibernation towards the breeding site. We didn't go necessarily all the way with them to the breeding site because we wanted to get the belt off of them before they went into the wetland, but we just wanted to track them note their initial orientation away from the hibernacula towards the breeding site, and then we took the belt off. And what we found with these 4 individuals is that they just never moved towards the breeding site. So we considered, and then breeding started, and they were still just sort of hanging around by their hibernacula. So we figured this was a non-breeding year for these individuals. And in 3 of the cases, they were females for sure. The other one was probably not sexually mature female. And with females, it's fairly physiologically expensive to breed. It's difficult for them. So we know from other research that they do tend to skip years. The average distance between where we caught the toads in the fall and then where they ended up hibernating was close to 500 meters, but again, we had quite a range. And then where we caught them in the fall to where they bred that following spring was over 1 kilometer. Now, we caught them in the fall and they would have been out foraging and moving around in the summer. So that more than likely that distance is quite a bit farther. We caught them when they were in their mid-movement towards the hibernation site. What was really interesting was that these toads followed very directional movements towards the breeding site in the fall and in the spring again. So the stars on this graph are a capture point of a toad, and then these funny little starbursts are the hibernacula. So if you figure out one line, if we track this one here, this is where the toad was captured, and then this is where it hibernated, and this is the breeding site. And what I want you to see here is that they're all moving fairly straight, and no matter where they're caught, what side of the breeding site they were caught on, they're all moving towards that breeding site. So they're trying to get closer so that when they come out of hibernation, they don't have as far to travel for breeding that following year. But what's important here is that they're not following any streams or usual travel corridors. They're not going from wetland to wetland or streams, which is often places where we'll put traditional buffers or corridor areas or protected areas. They're moving straight through the landscape. So that means we need to really be thinking about a landscape context if we want to protect toads. So let's look at one individual, T41, who moved 1,500 meters in the fall. And I want to emphasize this particular fella because he shows that a lot of these toads have to cross roads in order to get to their hibernation site or from hibernation to the breeding site in the spring. So this is where T41 was captured, and this was in September. And then here's the breeding site up here on the left. So we're just going to go through a sequence of relocations every few days. So sorry, that was the two different relocations. That's the first road crossing that he made. Then we do another relocation, second road crossing, and then he finally got to his hibernation site, and he'd made 3 road crossings between late September and early November. And this is typical of almost all the toads in this landscape. They have to cross roads constantly. So that really does put them at risk. So what was the maximum distance between hibernating and the breeding site? Remember, we had the maximum for the toads that were breeding that year was 1,660 meters, or sorry, 1,660 meters. But if we include these 4 non-breeders, then actually the distance is more like closer to 3 meters away. That's T15 here. So what I want to show is that we have some complications here when it comes to political boundaries and where these guys are moving. So if we just consider that first distance, which is just, if we just wanted to protect the guys that were breeding, the females and the males that were breeding in that particular year, this is what the radius would be around the breeding site. We can see that we're mostly in one political area, straddling a little bit over into the second one. But really we need to be protecting all of the breeders, as much of the population as possible. Well, now we need to go at least 3 kilometers away. Sorry, that wasn't based on T15, it was based on T11. And we see that we end up in 3 different political boundaries. So that makes things a little bit more complicated for how we're going to manage for these species. So based on that, that segues into, I just want to go through some of the needs and threats of toads if we want to do any sort of protection. So as we know from the previous study and from this study, we need to be able to safely move between breeding and hibernation sites at a bare minimum. They are also traveling farther within the landscape in the summer, but that's at the bare minimum. So the biggest threat to that is road density and your traffic levels. So we had a very high density of toads that were captured on roads within this red box here. So here is the breeding site here. So it was quite interesting, even though we surveyed all through this area, we had a very high density here. This also happened to be where we had the highest density of hibernation sites in the area. But unfortunately, this is also where we have a large number of areas that are slated for development right now in that area. In fact, this area to the south of Wake Lake here is, yeah, for sale right now, some of the properties. We know that all the toads, in order to get to the breeding site, are going to, at the very least, they're going to have to cross one of these 3 roads to get to the breeding site, unless they were coming through this very narrow corridor up on the side here, which we never seem to have any toads in that area. So if there's any sort of increase in roads in the area or traffic on any of the existing roads, we could potentially get to the point where we're going to have a loss of this breeding site. And there is a proposal, because of the development over here, there was talk of putting an extension on the road and having it come right through this area, which has a high number of hibernation sites. So the second need is they need to have high quality breeding sites such as Wake Lake. So anything that impacts the breeding site could lead to the loss of the local population. More specifically, we don't know all of the breeding sites. We don't know what the whole landscape context is, which is really challenging if you're trying to protect a species. There's some potential loss of riparian cover around Wake Lake because it does have some houses. There's a little bit of a covenant along the shoreline in some areas. Human access would be very detrimental. It has a very nice, thick, shrubby shoreline, which is not attractive to people to go into, but there's been talk at different times of trying to create an access or a trail or putting a dock in. All of those would be really bad. It leads to habitat degradation that could potentially introduce disease into the population or non-native species. There's been a lack of consultation or communication with experts such as ourselves when there's been road work around the lake. They, at a number of times, have had to go in and remove beaver dams because water was getting too high and was flooding onto the road. One of the times that it was drained was right when there was, or when the water level was lowered because the dam was removed, was right when during the egg laying period, which could leave eggs stranded and lead to high mortality. And then the second time they were doing road work was during one of the critical toad movement periods in the fall. And they were actually redirected traffic off of the main road onto one of the roads right around the breeding site. So the traffic went up probably tenfold right around the lake. So we probably had a very high rate of mortality that year. We know there's problems at the site with non-native and invasive species. There are green frogs and bullfrogs in the site. It's difficult to know what the potential problems there are. Generally, toad tadpoles are unpalatable to fish and bullfrogs, but there would definitely be some competition for resources. We put wildlife cameras out because we've noticed that we end up with some dead adults every year at some of our breeding sites, and this site included. And I did capture images of raccoon foraging in the area. The subsidized predators such as raccoons and the corvids like the ravens and the crows can be quite problematic because they do really well with people. They like living in environments where there are humans, and then they're very smart wildlife. They know how to get around the toxic skin of a toad. So that can be very problematic if their populations increase close to a breeding site. They also need high quality hibernation sites. So anything that impacts a hibernation site could be difficult or challenging for a toad population. More specifically, they need to maintain high habitat complexity above and below ground across the landscape. We know that toads are hibernating underground. So things that cause any sort of soil compaction, there's a lot of agricultural fields in the area and housing development, conversion to concrete, asphalt. Anytime we disturb the soils or cause compaction, we're potentially losing hibernation sites. We know that there's some loss of large wood and stumps when we have development, and the only way we're going to get large downed wood and stumps is if we protect some large trees in the area. Any conversion from natural vegetative cover or habitats to developed areas is going to be a problem. I would argue that in this context for toads and hibernation, forestry is only impacting them on a very temporary basis. In fact, it could create some habitat that they might like for hibernation and for thermoregulation. Development for housing, for industry, that's the biggest threat for sure. It's a permanent loss of habitat. Lastly, one of the biggest needs that these toads need, because of the high, the extensive distances that they're moving, is they need collaboration, cooperation, compromise, and communication. So we need to have local support from all levels of government, private landowners, and land managers. This is from in a number of different areas. We need to make sure that there's some sort of control over roads, how many roads that we're putting in, what's the traffic volumes, are there any sort of projections when we put houses in and development over the amount that the traffic levels are going to increase, factoring in underpasses where they're needed, and considering seasonal closures where that's appropriate. We need to protect potential breeding sites and existing breeding sites, so the wetlands, but we don't necessarily know where all the breeding sites are, so we need some sort of monitoring. Non-native species management could be a factor in some areas. Forest stands are really important, so even protecting very small patches of trees, any sort of incentives for that would be really helpful for toads and for all amphibians. And as I mentioned, stumps and woody debris are very important. So if we can retain large stumps and downed wood, that would be really good. The protection of larger trees so that we're continuing to have stumps and large wood, downed wood in the future. And that might take some education and some incentives. I just want to highlight a positive thing that came out of this research was I gave a presentation to the CVRD staff in November 2018. And when they were, they actually put toads and some toad habitat protection measures into their draft official community plan at the time. This was in February 2019. Under their forest policies, the lot, that area of land, that clear cut to the west of the breeding site that was being sold as a potential housing development, that is going to remain under forestry, so it won't be converted into housing, and that is really great for the toad population. That's one of the most important things. Under their parks policy, they want to acquire additional lands around Wake Lake and partner with others like the Ministry of Transportation to address some of the road issues. And what I was really excited about was under their rural residential policies, they were not going to support any further subdivision of rural residential lands within 2 kilometers of Wake Lake, which was very moving for me and is fantastic. Unfortunately, the proponent that I had, the planner at the CVRD, has retired, and I have a feeling this was one of her last kicks at the can before she retired. I'm not sure that any of these policies will necessarily make it through all the way into the final version of the official community plan, but it was really great to see that our research and our efforts to communicate our results was making an effect. I just want to finish off with some ideas of things that you can do if you have toads in the area where you live. We know that in the fall, we get a lot of mortality of toads and a lot of amphibian species in the fall. When you have those first rains in September, those really good first soaking rains, that's when a lot of amphibians move. So they've been kind of hunkering down and almost stuck for a couple of months during the hot, dry season. They're not really able to move around very much at that time. And so those first fall rains, when it's really, really raining, they're often moving at night. And if you can avoid driving during those first fall rains at night, then hopefully you'll be running into any amphibians. Supporting things like temporary road closures, like a river bottom road around this Wake Lake site would be really helpful. We get a lot of resistance with that sort of thing, even though there are other ways of getting around. People just don't want to be inconvenienced in any way. As I mentioned, monitoring and knowing where all the breeding sites is really important. So if you happen to have a wetland on your property and can do surveys for toads, that would be fantastic, and letting people know about that at the province. If you are in an area where you have toad that's coming through from a breeding site, we encourage people to really pay attention to when those movement periods are and avoid mowing at that time. And when they're doing yard work, like they're removing debris piles, large areas of, where they've got wood stacked up, you can end up with toads that are hanging out in the wood, other amphibians as well. Avoiding removing stumps would be really good, especially during the hibernation season. We had one fellow down in the Duncan area tell us that he took a stump out in the winter and there were something like 12 toads in there. We don't know the ability of the toads to be able to find a new hibernacula at that point because it's quite cold. And being cold-blooded, it's very difficult for them to move when it's that cold. If you can leave a stump in the ground, that's fantastic. I'd like to call them toad hotels. They're providing a lot of habitat for amphibians. We had cameras, as I mentioned, set at these stumps, and I have images of so many different species moving in and out of these stumps, so they really are important. And if you can provide any sort of cover for migrating amphibians or overwintering amphibians by retraining trees, shrubs, logs, stumps, and rock or wood piles, that's really helpful for these critters. I'd like to finish off by thanking all of the funders and all of our volunteer toad catchers, and especially all the people who gave us permission to access their land. I found that very, very touching that they would let these complete strangers go onto their land and track a toad, because if the toad hunkered down for a few days or longer, we were visiting, you know, every few days or every week. And I thought that was really nice that they would let people do that. In summary, landscape context matters for amphibians and for wetland conservation. Aquatic breeding amphibians are a great group that demonstrate the need to consider landscape context because they migrate between aquatic and upland habitats. They utilize upland habitats for most of the year, for example, for hibernation, and they follow very specific directional migration pathways. Although amphibians can be quite adaptable in some ways, they'll use a variety of upland habitats like clear cuts or agricultural areas and areas where there's rural development. Urban development and roads pose a major threat to their survival. Where you have increased urban density, you get increased road density and increased traffic volume. We need to protect natural wetlands and upland forest cover. The two are very important for amphibians. And we need to consider the landscape context if we're restoring or building wetlands. We have a blog site for our toad project, and there's some great videos there if you ever want to visit and see what our work was. And I'll take any questions. Oh, I think you're muted, Guy.
Okay, there's a question.
Oh.
It's Donna.
Yeah, so let's I just wanted to thank Elke so much. So we've still got 40 people with us. I think so many brains are learning so much. So let's Donna bring in. I'll unmute you. You're unmuted already. Donna, throw your question up first.
Oh, okay. I'm happy to wait.
That's okay. You go ahead.
Oh, we have a small pond in the front of our house for about 20 years, and there's a bridge over the pond with rocks all around. And over the past year, we've had like as many as 8, which we think are frogs. And I've researched it, and it looks like an Oregon spotted frog, but I don't know if that's the right frog. But this past summer, and we've got like a lot of plants covering over the pond. But this last summer, we only had a large male and a small female. And we don't quite know what's happened, but how can we identify that? I mean, I've got a picture of it. Is that something I could put on the site? Or we don't even, it could be, I mean, it's got to be a frog if it's in the pond, is that right?
So the Oregon spotted frog is only on the mainland, so it wouldn't be that species. The only true frog species, if that's the one you thought it looked like, would be the red-legged frog.
Okay.
Red-legged frogs in the heat of the summer, they tend to come closer to water bodies. They're more vulnerable to drying out than toads, so they will often hang out by the pond in the summer, but it doesn't necessarily mean that they bred at the pond. They could be just foraging or using it for hydration or for cover or something. Just because you're seeing more in some years and not other years, that doesn't necessarily mean that there's anything that's going amiss at the site or anything like that.
Okay, and it's so then is that that would be a frog or a toad?
If it's got smooth skin, then it's probably the red-legged frog. If you go to BC Frog Watch, you can look at red-legged frogs there. It's a good resource.
Okay, thank you very much.
No
So
problem.
I'm going to ask Kathleen Code. I think I muted you. Do you want to go ahead and ask your question about elevation?
Yeah, sure. I was wondering, you had mentioned toads, I think, in the first part live up to the 400-foot elevation. Is there a higher elevation that they exist at? Will they exist at the valley tops, at the top of the mountains?
Western toads actually go to, yeah, they go really, I can't remember the elevation off the top of my head, but they are considered to be a species that can go right up into alpine environments.
Okay, and my second question was, could the wetlands be deeper in clear-cut areas because the soil dries out a lot more in the summer and it takes longer for water streaming down to saturate the soil?
That's a good question. Generally at our sites, yeah, that's a good question. I don't think that that's what it is, but I think the biggest factor is the transpiration. But that's a good point.
Thank you.
So I have a question for myself. Does Wake Lake have a lot more toads than other wetlands? Or is it simply that because you've studied Wake Lake, you have detailed information?
Sorry, what was the end of that comment?
Or is it that because you've studied Wake Lake, you have more information about it compared to other wetlands? Is it more fruitful in toads than other wetlands, or you just know more about it?
Yeah, no, that site was chosen mainly because we had access to such a big volunteer base that we knew that we would be able to get enough toads in the fall, and because we could do road surveys. So it was really about being able to reach the sample size that we needed. We have other toad breeding sites on the island that have been monitored, and I would say that Wake Lake is, it's pretty average in terms of the population size.
So what it tells me, you've got the politicians thinking about what they need to do because you put that information in front of them, but they could have equal information for a whole bunch of wetlands around the Cowichan Valley.
Yeah, actually, toad breeding sites are really rare.
Oh, right. Okay.
Yeah, so that's one of the main reasons that we are also studying them. So this is a frustration of mine, is that toads were blue listed in the province. They are listed federally as species of concern. They were blue listed or threatened before, and they've been delisted to yellow.
Okay.
Red-legged frogs are still blue listed or threatened and federally listed. But Western toads here along the South Coast, their breeding sites are really rare. We think that they're in decline, but because the way that the scoring goes for the species status, you're having to think about the whole province in that context. And so I'm a big advocate for separating out Vancouver Island from the mainland when we're doing these status reports, because it's a different scenario here. We're limited in terms of how much immigration you can have, or compared to other areas. So the wildlife we have and the populations we have are limited on the island here. So
okay, Susanna has a question about tree frogs. Go ahead, Susanna.
Yeah, we have a pond. It's an urban property. In the front of our property, we have a pond that has bred tree frogs for all the years we've been here, and it's prolific. So you talked about thermal conditions. So one of my questions, I have a couple questions. One of them is, what's the ideal depth of a pond that we want to keep the tree frogs reproducing? You talked about that if it's warm, they can mature quicker, and that was a good thing. And another question is it valuable for it to dry out, or should it be standing water like deeper so that it keeps water all year long?
Mhm.
And the third question is that how do we have a corridor for them to go from the pond to the forest, which is behind our property, because there's a driveway that goes 3/4 the way around. So there's only one area for them to transverse that would be safe, which is kind of along a small drainage where the water drains from the pond down to the river behind us.
Mm-hmm. I'm going to answer the last one first, just and say, I don't think you need to worry about their ability to move. If they've been breeding in that pond for years, then whatever situation you have there works fine for them. They're generally moving at night. So If you don't have a lot of traffic, you don't have vehicles moving up and down the driveway. Driveway is not going to be a barrier to their movement. So I wouldn't mess with that too much. They're probably fine. Good questions around the depth of the pond and the hydro period. You are living in an area that does have a problem with bullfrogs and green frogs. So ponds that can dry out are not suitable for green frogs and bullfrogs because their tadpoles take more than a year to metamorphose. So they're only in permanent water bodies. So that's why a tree frog will do much better in an ephemeral pond. Having said that, the research is suggesting that in an area like here on the island, on the east coast of the island, where we have lots of bullfrogs and green frogs hanging out, we're basically starting to get more of we're at that stage of invasion species biology where they're getting a little bit more of an equilibrium or into balance. So if you have a permanent water body, if there's no way that you can dry it out in any given year, the more complex that wetland is in terms of depth and the amount of vegetative cover. You've got some open water, you've got cover, you've got different plant species. The more natural and complex that wetland is, the better it is for the native species because they just have places that they can hide away from the bullfrogs and the green frogs. So they can cohabitate if the habitat is complex enough. It's not ideal, but they can cohabitate. So a lot of times the problem is we create dugouts and stormwater ponds and these sorts of things that are just like a cereal bowl. They're just a big deep bowl with steep sides with almost no vegetation in them. And that's ideal for bullfrogs and green frogs and not great for our native species.
Mhm.
Yeah, it used to dry out, but bulrushes filled it up. So we've just recently taken out bulrushes and kind of deepened the pond. So I was curious about that.
Yeah, taking out the bulrushes is great. It's one of the species that I find the amphibians don't associate with at all. They prefer much thinner stemmed graminoids, the rushes and the sedges. So they're really small, like 2 millimeter, 3 millimeter sort of diameter little rushes and sedges. That's what they'll use to lay their eggs on, to attach their eggs. So the rushes are really great to get rid of. I wouldn't worry too much about increased depth. They tend to like to lay their eggs on the south facing shore of a water body where they're going to get the most sun in that early spring. So if that side of the lake has a nice gentle slope to it, or sort of the wetland has a nice gentle slope, then that will make it really attractive. And then a little bit of those thin stemmed graminoids, that makes it really ideal for breeding.
Okay, well, thank you. So we shouldn't dig it out deeper then, basically.
No, you don't need to make it deeper. If it's staying wet until at least July, then the tree frog should be fine.
So we got quite a few questions lined up. Ben Martman has a question about climate projections. Do you want to ask that, Ben?
Sure, thank you. And first, I'd like to thank you very much. This has been really informative, and I really appreciate it because we live on Mico Lake, and we are lucky because the frogs share 1,200 feet of it with us. And so every year I get to watch them live, and I didn't understand their migration habits and their hibernation habits. So it really helps me now to understand what they're going through. But my question is, the CBRD put out a climate projection report about what's going to happen over the next 30 to 70 years and what they're predicting for this and for this area. And what they're predicting in it is that we're going to see wetter winters and longer, drier summers, and potentially to the point where we have frost-free climate. And I'm wondering what does that mean to these species?
That's a great question. We have something in parts of the country where they have more calling frog species. We've only got the one frog that we can hear at the surface, the Pacific tree frog. If we had more species, this would be really fun. But what they do is they start marking on the calendar when the frogs start calling and when they start breeding. And what we are seeing in some parts of the country, like out in Eastern North America, is that they are calling earlier and earlier and earlier. So they're breeding earlier in response to climate change. It's very difficult to know what the effect is going to be. It could mean that we are going to be, I think that one of the biggest effects would be that a lot of these smaller ponds are going to be lost because they're just going to dry too quickly. but there's also the potential of some sort of weird physiological things through the winter. So we had a toad come up a bit early out of its hibernacula, and so we don't really know how well if somehow they're cueing into the temperature at the surface, even though they could be a meter or more, 2 meters down underground. Somehow they're cueing into the temperature of the surface. And I think that they just moving up near the surface. I would see on some of the photos where they would come near the entryway and then they would just sort of hang out and then they'd go away, and then I would see them come out later. So they're coming up and sort of checking the temperature, and then they're going back down. And I think, and what we noticed too was that they're hanging around these hibernacula for weeks to a month or more before they actually hibernated or when they came out of hibernation. So they're hanging around this site quite a long time. And so they're sort of, they can't forage too much in the fall before they go into hibernation, because they have to have an empty belly or the food will actually rot in their belly while they hibernate, and that can kill them. So it's a real chess game that they're playing in terms of knowing, like, when do you stop eating? When is it going to get cold enough that I need to go down and hibernate? I have no idea how they cue into all these different things. It's quite amazing, but they seem to figure it out. So whether or not they can adapt that fast, or if they've already just got an inherent adaptability, some species I would assume are just going to do better than others.
So here in area H, where we're living in the Yellow Point area, Ben is one of the 2 candidates running for election along with Murray McNabb. So if either of them get elected, they'll be in touch with you, I'm sure, about how we can do more protections on the land. I have a question from Dave Haley about incentives. Dave, do you want to ask that?
Sure. I noticed in a couple of your slides, Elke, you did talk about incentives, and then I was encouraged with the response you got from the Cowichan Valley Regional District. And then I guess because Ben is on the call, and maybe the representative, maybe be interesting if he went into a meeting with a list of incentives that would be good.
Your response?
So I'm thinking, you know, incentives for a private landowner to maintain or enhance both the wetland and then the transportation corridor up to the uplands.
Sorry, Dave, are you asking a question or are you just making a comment?
I'm asking if you've got any specific incentives that, you know, governments could put into place. Sorry to put you on the spot.
Yeah, that's a good question. To be honest with you, I don't really know enough about how incentives work. I just know the things that I'd like to see incentives around, like I mentioned, like trying to get. So one of the biggest things I really struggle with, what I see happening right here in Nanaimo and what I saw down around this toad breeding site is how wetlands get filled in, and there doesn't seem to be any kind of control around private property owners. Like I watched one right across the street from this Wake Lake site, and I'd see the dump trucks going in and out, and there's nothing I can do about it. And then the clearing of a property. So those 5 or 6 lots across from Wake Lake that are for sale now. I was in close communication with I think it was someone in the, I can't remember if it was the planning department or permitting or something, just trying to figure out how they would, what sort of limitations they might put on those developments. And I find it really frustrating when somebody moves rurally, buys a piece of property. In my mind, you're incredibly lucky to be buying such a beautiful property, and you're choosing to move into this rural area, and then I see them completely clear it. And I don't understand why you'd move somewhere rurally and then you would just cut all the trees down. And it's often associated with things like people who have horses was one of the properties, you know, and it's just turned into a big muddy paddock. And so if I could have people leave more, have incentives to leave any bits of any trees and even just bushes, you know, so it's not grass with the odd tree on it, but just a bit of shrub cover does an incredible amount for amphibians as they're moving through the landscape. But the thing that really worries me is that we're not planning things in this landscape context, right? Where we're just giving permits to a developer and then another developer and another developer. And are we thinking about what this cumulative impact is of all of these different impacts? Are we doing projections on what the traffic is going to be on those roads once all of those cumulative houses go in, or on our water sources or anything like that? So yeah, I think in terms of individual property owners, if there could be incentives for developers and for property owners to try and leave as many trees and vegetation on the properties as possible, I think that would help a lot.
Yeah,
So thanks. Kathleen's got another question around yellow flag iris. She's at Wildwood, so they got a massive amount of forestry and water there. Go ahead. Are you unmuted,
Yeah, I just muted myself because my dogs are getting kind of restless here, so they make a lot of noise. But yeah, at Wildwood, we have large swaths of yellow flag iris at that end of Quesnel Lake. And we thought we would try and smother them, but then we discovered that it's quite intensive frog habitat. So if we smother the iris, then we smother the frogs in their habitat. So I don't know what we can do. It's a bit of a dilemma.
Yeah, that's a tough one. I guess I don't know. I'm not familiar enough with what's entailed in the smothering. If you were to do it in September, for example, I don't know if what's the best time to smother it, but if you could smother it outside of the breeding season of most of the amphibian species, by late August, September, all of the larvae should have metamorphosed and moved out of the wetland, except for one particular species, the northwestern salamander. They're in the wetland all year round. What you could potentially do in a scenario like that is, again, it just really depends on the conditions. I don't know what the water body looks like, but just thinking off the top of my head is you could put in exclusion fencing around where the yellow flag iris is. So it's a submerged sort of exclusion fencing, partially submerged. And then you could trap or dip net within the yellow flag iris and get as many of the amphibians out that you can if there's any in that area. And then you could smother it. And so you would just catch them on the one side of the fence and move them over to the other side of the fence. So it's sort of what we do when we do amphibian salvage in a construction scenario. So I was working on one where it was a large ditch, and we just put exclusion fencing in part of the ditch, trap everything from one side and let it go on the other side of the fence. That's potentially one thing.
Right.
So Elke, it's coming up to 8:30, so we said we finished there. You are an absolute wonder of froggy and amphibian information. It's just, you're so rich in this information that most of us don't have. We live on the land and we need to know this stuff. So it's one thing I can hopefully encourage you with is in the Yellow Point Ecological Society, we're spending the winter writing a landowner's nature guide to the land that we own, the 1 acre lots, the 5 acre lots, full of this really practical information so that people can understand the habitat needs of the caterpillars, the birds, the amphibians, and how that affects the way they do development. And any opportunity, you know, I'm sure we'll be coming back to you at least for sort of proofing what we write and make sure you can check it. And Dave Haley says thank you to you and to everyone. I'm sure all of us say we can do a little big clappy thing for you. They're all muted, right? Because I know that I can feel, there we go. Yeah, you can experiment. Go to reactions, everyone on the board. At the bottom, you'll see reactions on the right-hand side. You can do a big clappy thing. There you go, look at all that.
That's great, thank you. I would be happy to review anything that you guys have. Yeah. It's very near and dear to my heart, amphibians in general. And yeah. I really like to make sure that people are getting accurate information. I'm always coming across information that's not accurate. So yeah, any way that I can help.
Pamela Walker, who is saying she's writing about amphibians, so she's going to be coming to you to make sure we get it right. So look, thank you so much. Thank you all of you for joining us. There will be a recording of this if all goes well. We'll post it to our website and let you all know about it. And have a great evening, the rest of you. Thanks so much, Elke.
Thanks.
Over and out.
Take care.
Bye-bye.
Bye-bye.